Hi guys, welcome back again. Today we will continue the ECG interpretation. So here we have an ECG. So before we say it's normal ECG, we have to exclude all of them. The first point is check the name of the patient and date with calibration of the ECG, as I discussed in the previous video. Okay, this is the first one. The second point is amplitude and conduction should be normal. So amplitude I discussed in the previous video. Okay, so here we have the conduction. In the conduction we look to AVR. Okay, in the AVR, because the AVR is totally negative deflection, so it's a normal conduction, right to right side, left to left, not right to left and left to right. Okay, so it's a normal conduction. Okay, then after exclude the conduction is normal, then we will jump to the sinus rhythm. In the sinus we have a point that we have to discuss. It's important to know that the sinus rhythm is any cardiac rhythm in which depolarization of the cardiac muscle begins at sinus node, SA node. Okay, so here, as you know, here we have the P wave. P wave is represent the atrial depolarization. So here we have the SA node that make the atrial to be contracted, then QRS, and then ST and T wave also. So here we have the normal P and QRST. Okay, this is P, QRST. Okay, so the sinus is a rhythm. We have to check the heart rate. The heart rate, as you know, the rate should be more than 60 and less than 100 beat per minute, as I discussed before. So a normal heart rate is between 60 to 100. So here, if the heart rate is more than 100, it's called tachycardia. Okay, so if it is below 60, it's called bradycardia. Okay, so it's important to know that how we calculate and how we know the heart rate of the ECG. Okay, so here we have regular heart rhythm. Okay, so it's a regular heart rhythm. For a regular heart rhythm, calculated by 300 over R to R interval. It means that between each R wave of the QRS complex, how many large square we have. For example, if it is 3 large square, so we divide the 300 over 3 large square, so it equals to 100 beat per minute. This is the way for regular heart rhythm. If a heart rhythm is irregular, calculated by count the number of the complexes on the rhythm strip, then multiply the number of the complexes by 6. For example, if you have an ECG which is irregular, okay, if it is like that, so if a heart rhythm is irregular, as I said, that calculated by count the number of complex. Okay, so here we have the QRS complex or R waves. Okay, So okay, here we have R waves of QRS complex. We count the R wave of QRS complex during 30 large square, or what we can say during 6 seconds equal to 30 large square. Okay, for example, if we start here through this point, this is the first large square, this is the 30 large square. So how many R wave we have here? For example, 1, 2, 3, 4, 5, 6, and 7. So here we have 7 R wave during 30 large square or 6 seconds. So multiply by 10 equal to 70 beat per minute. This is how we calculate in ECG if heart rhythm is irregular. So in general, heart rhythm can be regular, can be irregular. Okay, irregular also divided into regular, irregularity, and irregularity, like in a case of AF.